Today we're going to work on long division of polynomials. Division of polynomials can look three ways. It can look like a fraction, so polynomial 1 divided by polynomial 2. It can look the good old-fashioned way with the division sign. And it can also look like polynomial 1 times polynomial 2 to the -1 degree. And if you remember from when we did exponents, -1 means that when I put it in the denominator, it becomes a +1. And so really, this is just another way of writing this fraction up here. Here are the steps for long division. So go ahead and pause the video right now. Pause the video and write down these steps for long division. All right, so let's do some practice. So I'm going to take this polynomial and divide it by z minus 4. So I need to ask myself, what do I have to multiply by z to get z squared? So that's going to be simply z. So I'm going to go ahead and multiply through. So z times z will give me z squared, and then z times -4 will give me minus 4z. When we do long division, we're subtracting, right? So since we're subtracting, that changes this negative to a positive. That gets rid of my z squared, and now I have 6z. So now I have to ask myself, what do I multiply by z to get to 6z? So that's going to be plus 6. So 6 times z gives me 6z. And I bring down this 24, and now 6 times -4 gives me -24. Again, I'm subtracting. So that gives me a remainder of 0. So what this means then, and I just want to show you this full circle, is that both of these are factors of this polynomial, which means, like we've been talking every single time we factor, we should be able to FOIL, go backwards, and get the original term. So z times z is z squared, plus 6z minus 4z minus 24. And then I'm going to combine like terms, and that gives me z squared plus 2z minus 24, which was my original polynomial. So I just wanted to show you that full circle. This part right here is not something that you have to do when you do this problem, when you're told to divide by long division. This is just, I wanted to show you how it works. Okay, let's do another one. So same idea here. It's just been written differently. So we're going to go t squared plus 3t minus 9. Because remember, this is the same as having it in the denominator. All right, so something's wrong here. And if you're looking at this, hopefully you're thinking, this is just going to be really hard to end up with the t squared here and make everything cancel, and it's just going to be a hot mess. Well, that's because we always have to order these terms. If you look back at your steps, very first thing we have to do is order our terms in decreasing order. So this is not how I want to write this. Rather, I'm going to change the order here. Signs stay the same, just changing the order. And now I'm going to be able to get this to work. So, okay. So what times -t will give me t squared? Well, it's going to have to be -t, because that negative times negative will give me a positive. T times t is t squared. And so then -t times 5 is going to be minus 5t. Again, remember we're subtracting here. So that changes that sign. And now that's going to give me 8t bring down this 9. All right, again, I've got to ask myself, what times negative t will give me 8t? Well, that's going to be minus 8, because negative times negative is positive. And now I've got negative 8 times 5. That's going to be negative 40. Remember, we're subtracting, so our signs change. And now that's going to give me a positive 31. And this is my remainder. So when I write this, I'm going to write this second factor as negative t minus 8, and then it's a positive 31, so plus 31 over whatever I divided it by originally, so negative t plus 5. So what we're saying is the remainder, 31, into negative t plus 3. So in order to factor this, it doesn't factor perfectly. So negative t plus 5 is not a factor of this polynomial. So I have to write my remainder, and that's my final answer. Okay, let's do this one. So now I have a polynomial to the 4th degree. Process is the same. Didn't leave myself a whole lot of room there. Okay, so 2y minus 1. Okay, so what times 2y will give me 4y to the 4th? So I'm going to need a 2 to get me that 4. And I'm going to need y to the 3rd to get me that 4y total. So 2 times 2 is 4, y to the 3rd times y is y to the 4th, and then I've got my minus 1 here, so 2 times negative 1 is negative 2, y to the 3rd. All right, again, I'm seeing another problem here, right? Because when I subtract these two, I can't. They don't have the same y term. So this is one of those things that sometimes we forget to check at the beginning. But if you again look at step 1, we're told that we need to fill in any missing terms with a 0. So I wanted to show it to you this way so that when you have something like this happen, you know what to go back and look for. So we need to add in our y to the 3rd term. So let's try this again. So 4y to the 4th plus 0 y to the 3rd minus 5y squared plus 2y plus 4 divided by 2y minus 1. All right, so let's try this again. So we already discussed that we need 2y cubed. So 2 times 2 is 4, y to the 4th. All right, then minus 2y cubed. Look at that. That looks so much better. Now, mind you, we're subtracting here, so we got to switch our signs. So that's going to give me 2y cubed. Bring down my 5y squared. Now I need to ask myself, what do I multiply by 2y to get 2y cubed? Well, the only thing I need in this case is y squared. So that's going to give me 2y cubed minus y squared. Subtracting, switch my sign. So now I have negative 4y squared. Okay, so now same deal. Got to ask myself what I'm going to multiply 2y by to get negative 4y squared. So I need to minus, subtract 2y. So now I have negative 4y squared. Oh, got to bring down my 2y. And then negative 2 times negative 1. It's going to be positive 2y. Again, with the changing the signs because I'm subtracting. So this leaves me with 0. Got to bring that 4 down. And so that's going to leave me with a remainder of 4. So let me make sure this is all on the screen. I have right up here 2y cubed plus y squared minus 2y, and then my remainder plus 4 over 2y minus 1.